Okay, number 30, again on this section, 2.3. So we're given this fourth order homogeneous linear equation, differential equation. And so again, let's find the characteristic characteristic equation, which is going to be in the form of a polynomial. So we have y. So again, my r is going to be y prime. So I'm going to have r to the fourth minus r cubed plus r squared minus 3r minus 6, right, because my y doesn't have a derivative, is equal to 0. Okay, so we have our characteristic equation, and again, the goal is to factor this guy, right? Can we factor this by using maybe a greatest common factor? Well, we definitely know it's not quadratic because the highest power is 4. So quadratic formula is out. Let's see, any GCF and no GCF, not in all terms, right? Maybe here and maybe here, but then we don't want to leave our negative 6 alone. I mean, we could factor an r from here and here, but it's not going to help us in our goal. So we are probably going to be using the rational roots theorem. So rational roots theorem from Algebra 2. So we have, so it's this guy, right? Now, again, don't focus on that negative 6. It's just 6 over 1. Okay, so 6 over 1. Okay, so we have 6. So then again, what are the factors? Again, not necessarily prime factors, but what are the factors of 6? And the factors of 6 are, so let's go ahead and write, let me write it out. So factors of 6 are plus or minus 1, right? 6 is divisible by 1. Plus or minus 2, plus or minus 3, right? And plus or minus 6. Each of these numbers is divisible by 6. And again, we include plus 1, minus 1, because we're looking for integers, so positive numbers and negative numbers. So one of these, right, there's 2, 4, 6, 8 possible roots. Whoops. 8 possible roots. Now we know that, I mean, one of these, right, is going to be one of our integer roots. It might be more than one, but remember our polynomial, right, is 4, so I should have 4 roots. So, I mean, obviously 4 of these don't work. But for now, let's pick one by trial and error. So I don't know, I'm going to just pick 1. So 1, so I'm trying 1, right? So, well, try 1. And I'm going to use synthetic division, so 1. And my polynomial, my coefficients are, let's see, I have my 1, negative 1, 1, right, negative 3, and negative 6. So 1, negative 1, 1, negative 3, and negative 6. And notice I don't have to insert a 0 because there is no missing 0, right? It's descending nicely. 4, 3, 2, right? That's really 1. That's really r to the 0, which we don't need to write. Okay, so let's perform our synthetic division, right? This guy always drops. So 1 times 1 is 1. If I add those, 0. 0 times 1 is 0. If I add these, I get 1. 1 times 1 is 1. I drop that down, I get negative 2 times 1 is negative 2. And if I add these, I get negative 8. Okay, this is my remainder, and I want my remainder to be 0. So this is not 0, so okay, that doesn't work, which is fine. That just means it's not going to be 1. So we can, again, if you want to write these out, but it's not 1. So, well, let's try -1. So -1, and again, 1, -1, 1, -3, -6. I'm going to switch to white here. And again, drop down that 1. 1 times -1 is -1. I add these, -2. And again, multiply these guys. So -2 times -1 is 2. Add, I get 3. Multiply, I get -3. Add -6, right? And then finally, -6 times -1 is +6, which is great because these are opposites, so we get 0. So we're happy campers. It means we don't have to do any more synthetic division. So one of the roots is -1. So let's see. One of the, well, so one root may be right. One root is, okay, is negative, well, let's maybe write that in, let's write it in, might as well use our notation. Okay, so I'm going to call R1 is -1. Okay, that also means that R plus 1, or R1 plus 1, is a factor, right? Because if you set that factor equal to 0, I mean, what's R1? It's got to be -1. Okay, so remember this, when we did the synthetic division earlier with our order 3 polynomial, right? We found one root, and then our quadratic became a cubic, and we were done. Well, sorry, our our cubic became a quadratic, and then we used the quadratic formula. Well, here, okay, so if we write r plus 1, okay, what's our resulting polynomial? Well, I started with the 4th root, so this is going to be r cubed minus 2r plus, r cubed minus 2, oh, whoops, r squared plus 3r minus 6. Okay, so we have our first root, but we can't use the quadratic formula yet. Why? Because, well, this is not, it's not a quadratic, I mean, if the r cubed wasn't there, then this is a quadratic expression. If you'd like, oh, this one's actually kind of nice. Well, okay, so there you have a couple of options here. If you want, you can, again, out of all the possibilities, the possible roots, you found that -1 was a root. You can try testing, 2 or -2, 3, and 3, and then eventually find another 0, and you'll find the root, which is fine, but, I mean, I would work with this polynomial if you can. And I'm noticing that, let's see, well, I'm going to try to, I know I can factor an r here, and I can factor a 3 here. So I'm going to try factor by grouping, right? And from algebra, factor by grouping, remember, is if you have 4 terms, and if you can if you can factor GCF from each 2 terms, it's called factor by grouping because you're grouping the terms. So in this first group, we could definitely take out an r squared, and what's left? R minus 2. Ooh, this is going to look nice. I can see it already. 3, all right, so plus, and then what is our GCF here? Well, we can factor out a 3. What's left over? R minus 2. Oh, I'm excited. This is good. So factor by grouping, whoops, we notice that there's an r minus 2 in common, so I can factor that out. So if that factors out, I'm left with r squared plus 3. Okay, this is very good news. So let's write out our second integer root, right, or integral root. whoops. No, I don't want to write that. I want to write, okay, so I have, okay, my first R1, right, is right here. Well, let's write it again. It doesn't hurt. So my first R1 was -1. That's my root. My second root that I found was, well, I mean, I have R minus 2. So if I, set this equal to 0 and I solve for R, that's got to be 2, right? So if you use 2 in synthetic division, you would actually get a 0 with the little smiley face. So now what is R3 and what is R4? Because it's a fourth order differential equation, or from our characteristic equation, right? It's a fourth order polynomial, or I should be careful, I shouldn't say order, fourth degree polynomial when I'm referring to the characteristic equation. So here are my, again, integral roots, which I'll probably be using that nice theorem, C1R1X, right? Well, let's write it out. It doesn't hurt. C1, C1 e to the R1x plus C2 e to the R2x. Okay, so let's leave that there for now. And what about R3 and R4, right? What are the roots going to be? Well, we're still left with, let me get a different color here. We have this guy, right? And this is not too bad, right? This is going to be the blue part. Well, R squared plus 3 equals 0. Okay, this is not a difference of two squares. This is a sum of two, well, it's definitely not a difference of two squares because actually 3 is not a perfect square. I was thinking of 9. But we do have a sum of something squared and some integer. So if you just solve for r, this is going to be r squared equals, right, and then just bring that 3 over. And then if I use the square root property, right, I'm going to get r, right, use a square root property, plus or minus. I'm going to get plus or minus, okay, the square root of -3. Okay, again, I have that negative 1 in there, which means I'm going to have an I. So r is going to be equal to plus or minus, and then this is going to be I radical 3, right? It's not the radical, it's not a 25, which could be 5. It's not a perfect square, or 9, or 16. So this is fully simplified. Another way of writing it is you can write the square root of 3, but just be careful, the I has to be outside of the radical. So I know that R3 is going to be I radical 3. And I'm actually going to write, you'll see why this is important in just a bit, but I mean, I'm going to add this 0 here, 0 plus I radical 3, which is the same thing. And then if I write R4, and this is going to be negative, right? I want the positive and the negative, I radical 3, right? Or 0 minus I radical 3. Okay, so these are my complex, right? Because there's an I complex conjugate pairs, right? Which is the same thing as this guy. It's just a shortcut. I mean, that's a short way of writing these two. But again, I emphasize the 0 because my 0 is going to be A, and my radical 3 is going to be B, right? Because it has to be an A plus BI form. So using theorem 3, and actually I'm going to stop here because it's 4 minutes and 22 seconds, and I can only go up to 15 minutes, or yeah, 14 minutes. And it's okay. So I'm going to stop here, and then I'm going to write the solution in the next video.